This is the second discrete probability distribution, the Poisson distribution. Describes a process that extends over space, time, or any well-defined segment, interval, or unit of inspection. So always here, the experiment would happen over space, time. We will call them segments. Okay, we'll call it segment of time, segment of space, or interval of time, interval of space, or unit of time, unit of space. Okay, in which the outcomes of interest occur at random. Of course, this is for all distributions. Always the outcomes occur at random, and the number of outcomes that occur in any given interval are counted, and that's why it is discrete. So if you can count the outcomes, it's a discrete distribution. فالباينوميال counted, outcomes والبوسون counted, والhypergeometric أيضا counted. Okay, is used when the total number of possible outcomes cannot be determined. And this is the main difference between this distribution and the binomial distribution. We don't know the total number of possible outcomes. So let us take some examples. The possible numbers of successes are integers 0, 1, 2, and we don't know where to end because we don't know the total number of possible outcomes. So number of successes, if you remember, we denote by x in the binomial, and also here in the binomial x runs from 0 to n because the number of trials is determined. Here the number of trials is not determined. Okay, so the total number of outcomes cannot be determined. We would like to know the probability of each of these values. We will take a formula to find the probability of each value. For example, what is the chance of getting exactly 4 emergency calls in a particular hour? So what is the success here? What is the chance of getting exactly 4 emergency calls? The success would be getting an emergency call in a particular hour. That's the success. What is the failure? We do not get the emergency call in a particular hour. Do you know? Of course, we can know how many times we receive calls. We can count the number of calls. For example, here we know that he could give me the average number of calls in a particular hour. But the thing that I don't know, the number of people who did not call the emergency in that hour, the failure. This is something I cannot count. Okay, so I don't know the total number of possible outcomes. Also, what is the chance that a chosen 1 mile stretch of freeway will contain 0 potholes? So notice that here particular hour is the segment, is the interval of time. Also here 1 mile, this is the segment of space. Okay, 1 mile. We are talking about always a segment of time or space. That a chosen 1 mile stretch of freeway will contain 0 potholes. So either the stretch of freeway contain potholes, or it doesn't contain potholes. We can use the Poisson distribution to answer these questions if we make the following assumptions. So these are the 3 assumptions of the Poisson distribution. Lambda is the average number of successes in 1 segment. So that's important. In 1 segment, we will call the average in 1 segment lambda. For example, we might know there is an average of 8 emergency calls per hour. So lambda is 8. Or an average of 15 potholes per mile. So lambda would be 15. Notice, per mile, per hour. This is the interval. This is 1 segment, 1 segment. So if you give me the average in one segment, it is called lambda. The probability of X successes in a segment is the same for all segments. Okay, so probability of success does not change from segment to segment. And also what happens in one segment is independent from what happens in the other segment. So no influence. Okay, for example, the number of calls arriving between 9:30 to 10:30 has no influence on the number of calls between 11 and 12 midnight. فindependence, probability of X successes does not change, remains the same from segment to segment, and probability, the average number of successes per segment is called lambda. Now, if you know lambda and you have different segments, so any number of segments, if you have different segments, we will call T the number of segments. So here, per hour, if you talk about 3 hours, then T would be 3. Here, per mile, if you mention 5 miles, then T would be 5. So T is the number of segments. And if you multiply lambda times T, the average per segment, and the number of segments, you get mu, or the mean, or the expected number of the Poisson distribution. Some examples about Poisson distribution. Number of patients who arrive at a hospital emergency room per hour. This is our segment. Number of patients. So how many patients could arrive at emergency room? How many? You can say 0, 1, 2, or. There is no upper limit. You cannot say until 10. Maybe 11 will come in an hour. Maybe 20 will come in an hour. Okay, you don't know where to stop. Number of calls the Dell technical support receives in a 30-minute period. So this is the segment he is talking about, and he is counting the number of calls. He could receive 0 calls, 1, 2, 3, 4. We don't know, up to Allahu A'lam. It continues. Number of cars served at the gas station in 24-hour period. Okay, so this is the segment. Number of defects per square meter of leather. So square meter, this is the segment here. All of these are examples about Poisson distribution. Now let us take the formula, Poisson probability distribution formula, how to calculate the probability of X. What is X? Number of successes in T segments, in all the segments, okay? What is lambda? Number of segments, lambda, expected number in one segment, average in one segment. T, number of segments. So T, number of segments, lambda, average per segment, X, number of successes. All of these three should be given in the question, so I can find the probability. If you know lambda T and X, you can use this formula. Lambda times T, which is the mean, you raise it to the power X, and then you take X down factorial, and then you multiply this by e to the power lambda T again, but with negative sign, e to the power negative lambda T. What is the mean of a Poisson distribution? We said that the mean is lambda times T. That's the mean. Okay. The square root of the mean is the standard deviation. If you square the standard deviation, you get the variance. So this means that the variance and the mean are equal for the Poisson distribution. So the mean is lambda T, the variance is lambda T, and the standard deviation is square root of lambda T. And let us solve some exercises. At a Major League Baseball park, 5 customers arrive at a concession stand on average. So he will give you always the average per unit of time. So here, What is the average? 5 customers. What is the unit of time? 10-minute period. So this is what? This is lambda. Lambda is 5. The average is 5 per or in 10 minutes. So each 10 minutes, the average is 5. All right. So this is lambda. What is the probability that in a 10-minute period, if he is asking about 10-minute period, it is the same segment we are using. So this means T is 1. Number of segments is 1. If he says in a 20-minute period, then T is 2. If he says in 30 minutes period, then T is 3. Okay, what is the probability that exactly 3 people, so he is asking about probability of 3 will arrive at the concession stand. Okay, how to find probability of 3? We use the formula lambda times T, so 5 times 1 to the power x times e to the power negative lambda times t, which is 5 over 3 factorial. And you can use the calculator to find the answer. You can write 5 to the power 3 times e to the power, e the number in the calculator, e to the power negative 5 5 to the power 3 times e to the power negative 5 over 3 factorial. You know how to use 3 factorial. The answer is 0.14. So that's the probability of 3 people will arrive in 10 minutes period. The average is 5. The average is 5. The probability that 3 will arrive is 0.14. Find the probability of 3 or fewer. 3 or fewer means less than or equal to 3. So he's asking about probability of x less than or equal to 3. This means he is asking for probability of 0 plus up to probability of 3. Okay, and he says in 20 minutes. 20 minutes, this means t is 2. The number of segments is 2 because our segment is 10-minute period. So 20 means t is 2. Of course, lambda is the same. Lambda is 5 per 10 minutes. So how to find this probability? I can use the summation symbol in the calculator. I can write it summation probability of x, where x is from 0 to 3. And then I write the formula of probability of x. What is the formula? Poisson distribution. Lambda t, lambda times t, this is 10 to the power x. X here is changing, so we just write it x times e to the power negative 10, okay, over x factorial. You put it in the calculator, and in the calculator you will need to put here multiplying, and you will put parentheses. You just put it like this in the calculator and you will get the answer. Okay, it would be 0.01. I'm not sure. Let me check. Summation 10 to the power x alpha, you can use alpha x times e to the power negative 10 over x. You can use alpha again, and you put the factorial, and then you write from 0 to 3. The answer is, yeah, 0.01. That's the answer. So here, notice this is in 20 minutes, okay? This is the probability of 3, but in 10-minute period. So probability of 3 in 10-minute period is much larger than probability of 3 in 20-minute period, because the average in 10-minute period is 5, the average in 20 minutes period is 10, so we expect 10 to come on average. The 3 has very small probability. All right, another example. The mean number of errors per page So this is our segment. Missed by a proofreader at a major publishing company is thought to be 1.5. So what is 1.5? It is lambda. Lambda is 1.5 per page, one page. Okay, so this is lambda. With the number of errors distributed according to a Poisson distribution. If 3 pages are examined, 3 pages are examined means T number of segments is 3 pages. Okay, so what is the probability that more than 3? So more than 3 means greater than. What is the probability that's more than 3? So greater than 3. So we need to find the probability of x greater than 3. What is the probability that more than 3, greater than 3 errors will be observed? Now, how to find probability of x greater than 3? We know it is probability of 4 greater than 3 plus probability of 5, but where to stop? We don't know. Okay, it doesn't end. So how to find probability of x greater than 3? You have to write it 1 minus probability of x less than or equal to 3. So you will subtract from 1 the probabilities from 0 up to 3. Because from 0, probability of 0 upwards is 1. So if you want to find probability of 4 plus probability of 5 plus, you write it 1 minus probability of 0 to probability of 3. You can use the calculator here. You can write it 1 minus summation probability of x, where x is from 0 to 3. So you can write it 1 minus summation x from 0 to 3, and you write probability of x using the Poisson distribution. Lambda times t, lambda 1.5, t3, so 3 times 1.5, 4.5 to the power x times e to the power negative 4.5 over x factorial. And if you put it in the calculator, you don't forget to put times here, and there are parentheses here, and you can find the answer 1 minus this answer. Okay, 1 minus this summation. Another example, arrivals to a bank automated teller machine are distributed according to a Poisson distribution with a mean. So the mean is always given in these questions about Poisson distribution per 15 minutes. A mean equal to 3 per 15 minutes. What is the meaning of this? Lambda is 3 in 15 minutes. Okay, each 15 minutes. So the segment 15 minutes. Determine the probability that in a given 15-minute segment, so t is 1, 15, 15, no customers will arrive. So what is the probability of 0? Number of customers is 0. All right, lambda times t is 3 to the power 0 times e to the power negative 3 over 0 factorial. So it is in fact e to the power negative 3. What is the probability that fewer than 4? So less than 4, fewer than 4 customers will arrive in 30 minutes. All right, what is our segment? 15. So if he says 30, then t is 2. And what is lambda? Lambda again is 3. All right, so we need to find probability of x less than 4. Well, what is the probability of x less than 4? From 0 up to 3. So you can use the summation notation, probability of x, where x runs from 0 to 3. Now, what is the formula for the Poisson distribution? Lambda times t, 3 times 2, 6. to the power x times e to the power negative 6 over x factorial. And remember, in the calculator, you will have multiplication here and parentheses here, and you can find the answer using the calculator. Another example, if a random variable follows a Poisson distribution, lambda is 20, t is half, find the expected value. The expected value is the mean is lambda times t. So it's 20 times half, so it is 10. The variance, well, the variance is exactly equal to the mean. The standard deviation is sigma, and it is square root of the variance. Probability of exactly 8 successes. Probability of 8. What is it? Lambda times t. Lambda times t is 10. 10 to the power negative 10 to the power 8. Okay, 10 to the power 8 times e to the power negative 10 over 8 factorial, and you can find the answer. One last example, determine the following values associated with a Poisson distribution with lambda t equal to 3. So lambda t here equals 3. What is the probability of x less than or equal to 3? You can use the calculator, summation p of x, x from 0 to 3. You can write the formula of the probability of x for a Poisson distribution. Lambda t is 3. You raise it to the power x multiplied by e to the power negative 3 over x factorial. And remember, in the calculator, there is product and there are parentheses here. Now you can find the answer from the calculator. And let me show you now also the Poisson distribution table. There is a cumulative Poisson probability distribution table. We mentioned that cumulative means less than or equal to all, so all the numbers here are less than or equal. You need lambda t, which is the mean. There are a lot of lambda t in bold here. So for example, to find this probability less than or equal, you can find it directly from the table because it's less than or equal. Lambda t is 3, so search for 3. The largest is 0.09, 1, 2, 3. So this is lambda t is 3. This is the column we need to search in. Okay, so this is our column. Now what do we need to find? Probability of x less than or equal to 3. This is 3. So less than or equal to 3 would be this number. So 0.6472. So if you use the calculator, the answer should be 0.6472. Now, can I find greater than from the calculator? Okay, directly no. From the table, directly no. What should you do? You need to write it 1 minus because you don't have the end. You don't know where to stop. Okay, greater than 3, 4, 5, up to where? In Poisson distribution, there is no specific number. So you have to write it 1 minus probability of x less than or equal to 3. Greater than 3, we need 4 and above. So we take 3 and below. 1 minus probability of x less than or equal to 3, which already found in part A. So you can just write the answer. What about from 2 to 5? Well, notice here that 2 is not included. So in fact, I need to find probability of 3, probability of 4, and probability of 5. You can do that by using the calculator, probability of x from 3 to 5. Okay, and you can write the formula and put it in the calculator and find the answer. Px, the same exactly like this one, 3 to the power x, because lambda t is 3 times e to the power negative 3 over x factorial. The same formula, but from 3 to 5, not from 0 to 3, and you will get the answer by the calculator. Okay, how can you find it from the table? Well, the table gives you less than or equal. It doesn't give you from 2 to 5. So what should you do? You can write it, probability of x less than or equal to 5. Now, if you look to this number in the table, which is probability of x less than or equal to 5, it would be at 5 here, okay? 0.9161. So probability of x less than or equal to 5 is 0.9161. 0.9161. Yes, this is probability of x less than or equal to 5. But do we need probability of x less than or equal to 5? No, I need 3, 4, and 5. So I have to subtract what? What should I subtract? X less than or equal to 2. If you subtract less than or equal to 2, then you will have only 3, 4, and 5. You have to write it less than or equal because in this table you only have less than or equal. So how to find less than or equal to 2? You look at 2, 0.4232. So 0.4232 is the probability that x is less than or equal to 2. If you subtract these values, you get the probability that x is between 2, greater than 2, less than or equal to 5. And if you use the calculator, you should get the same answer. So the answer is 0.499. Now the last part, find the smallest x prime so that probability of x less than or equal to x prime is greater than 0.5. Let us try to understand this question. X prime is a value of x, and x values are 0, 1, 2, 3, 4, and so on. Okay, so he needs the smallest x prime. So we know, for example, from part A that probability of x less than or equal to 3, probability of x less than or equal to 3 is 0.6472. So is it greater than 0.5? Yeah, the answer is yes, 0.6 is greater than 0.5. So probability of x less than or equal to 3 is already greater than 0.5. So could 3 be the answer? You have to make sure that it is the smallest x prime. Smallest means you have to check probability of x less than or equal to 2. Is it greater than 0.5? If probability of x is less than or equal to 2 is greater than 0.5, then the smallest is not 3, the smallest would be 2. Maybe also you have to check less than or equal to 1. Okay, but here remember we evaluated this from the table, probability of x less than or equal to 2, and we find that it's 0.4232. Is it greater than 0.5? No, it is not. So what is the smallest x prime? The smallest x prime is the number 3. This was the last example about the Poisson distribution. I stop here, and inshallah next time we will talk about hypergeometric distribution.